All right, so today we're going to start talking about something called an ellipse. An ellipse basically is, we want to think of it as an oval. An oval is a shape that you have been familiar with, probably, hopefully, since kindergarten. But they called it an oval, not an ellipse. An ellipse is another conic section, like the parabola, like the circle. Okay, but it's got a slightly different equation. It also has two foci, which we'll talk about in a second. I think it's actually easier than the parabola, but you might not agree with that. So we have two pictures here. Okay, um, one is a horizontal major axis, and the other is a vertical major axis. So this line right here is the major axis for this one. And then this line right here is the major axis. Okay, basically it's an axis of symmetry. Okay, and basically what we mean by major axis is whichever one is longer. Okay, all right, the shorter one on this one is going to be the minor axis. Okay, and the shorter one on this one is horizontal, and that's going to be the minor axis. So let's mark those. Okay. So you'll notice that these are both centered at the origin, okay? But we can center an ellipse anywhere. Okay, you will also notice that along the major axis, we have 2 points called foci, which are right here on this one, and right here on this one. Okay. All right, now these two graphs or these two pictures don't show something that Edgenuity does bring up, which is called a directrix of the ellipse. We will get into that in a little bit. But let's talk about equations and how we get from an equation to a graph. Okay, so we're going to start with being centered at the origin. Okay, now what's kind of nice is if we're in standard form for an ellipse, we always equal 1. Okay, so there are technically two different standard forms. This one, the major axis is horizontal. Okay, all right, and then the next one, the major axis is vertical. Okay, now you'll notice that pretty much the only difference in these two equations is where the A and the B is. A is always associated with the major axis. B is always associated with the minor axis. Okay, so let's talk about how we get to know where the how long that major axis is, how long the minor axis is. Basically, all the information you need is contained in the equation. Okay, so if we look at A, and we take the square root of it, okay, that is going to be the distance from center to the endpoints of the major axis. Okay. All right. So the entire length of the major axis is going to be 2 times A. Okay. With the center of the ellipse being in the middle. Okay. For the minor axis, you're going to take the square root of B, and that's going to be the distance from the center So the length of the minor axis is 2b. Okay. All right, now let's talk foci. Now, the ellipse is the set of all points where the distance between the sorry the distance between the two the difference of the two foci to the point is always the same. So let's go back to our picture. So if I find this distance, let's call this d1, and let's call this d2. If I take the difference of these, it's always going to be the same. So difference means subtraction. So let's get rid of this for a second. So if I choose a point here, and I measure this distance and this distance right here, and I take the difference, it's going to be the same difference as it is for this guy, which is really kind of weird. Okay, but it does work. You do kind of have to think about it a bit. It's easier kind of to show it in an animation or physically. So, but let's work on how we find those foci. Okay. So to find the foci, okay, first of all, the foci will always be along the major axis. Can't spell today. Okay, which means they'll always be inside the parabola. Not parabola, ellipse. So if you find yourself graphing an ellipse on paper and you're graphing your foci and they're outside the ellipse, something's wrong. Okay? The formula for finding the foci is actually pretty simple. Okay. Okay, you're going to use this number called C. You're going to take the square root of a squared minus b squared. So major minus minor. Okay, remember a is always associated with the major axis, the b is always associated with the minor. You should not get negatives. Okay, we don't want any complex numbers rolling around. Okay, and how to find those foci points is you're going to count C from the center on each side along the major axis. Okay, so we're just going to jump in and try one. Okay, I'll try to make it nice. Okay, so first example. So we're going to go from equation to graph. Okay, we're just going to make this one super friendly. Okay, this one, since it's x squared, y squared, we know that the center is at 0, 0. Okay, so remember, a squared is always the bigger one. Okay, so that would be 25. So the square root of that obviously is 5. So that would be associated with our major axis. Okay, b squared is going to be 16. So square root of that would be 4. And this is associated with our minor axis. Okay, all right, and now c. Okay, and we can also write c squared. You might see that as well. Okay, which is a squared minus b squared. So take the square root of that. So c, which is associated with the foci, but it doesn't tell you where they are, just associated with it. Okay, all right, so let's try to take all this information and graph. Okay, so our center is at 0, 0. Now we're going to count out major axis is below the x. So we're going to count out a horizontal major axis of 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So negative 5, 0, 5, 0. Now we're going to do minor axis. It's going to be 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that gives us our ellipse. Okay. So very carefully, and mine usually look like footballs. or alien heads. Like that. Whoops. There we go. Okay, snap to a circle for me. Okay, so that's an ellipse. Okay, so now let's do the foci. So we know that the major axis is along the horizontal. So we find our center again, and we're going to basically count out 3 on each side. So those are our foci. Okay, so there is a little something extra that Edgenuity does bring up. Okay, and it's called the directrix of a ellipse. Okay, so this would be a little bit extra. Okay. All right. So the thing to know about um, the directrix of an ellipse is there are 2 of them. I don't know how to spell the plural directrix. Okay. So we're going to use the letter D for that. Okay. Another thing to know about the directrix is it is perpendicular to the major axis. And parallel to the minor. Okay? All right. The formula you're going to get, or you're going to use, is this. D is equal to a squared divided by c. Okay? So you're going to get a fraction. Okay? So let's take our a squared, which in this case is 25, divide it by c, which is 3. So 25 divided by 3 is going to be 8 1/3. Okay, now from your center, okay, always go back to your center. Count out 8 1/3. 1, 2, 3, 4, 5, 6, 7, 8 1/3. And then you're going to draw a line. So that's going to be your first directrix. Okay, should say x equals. Okay, and then we're going to go back to center. We're going to do the same thing. And that's going to be your second directrix, just like that. Okay, so that is your very first ellipse centered at the origin. Okay, so we're going to stop right here because I don't like to make videos longer than 20 minutes and I've been talking too much. And then the next video, we'll do another one, we'll do another one, and we'll do another one. Okay, so I hope that was helpful and have a wonderful day.